Friends, today I'm going to design 5-volt power supply. A power supply is a device which converts the main AC into a DC voltage. So for us to have a power supply, we have to discuss some few things. So a power supply, we have said that it converts the main AC to DC. So meaning it takes alternating current as the input and give a DC, a direct current as the output. So in the process of conversion is what you're going to discuss how to design a 5-volt power supply. What are the stages that this has to pass through so that we get DC? How do you choose component for you to be able to design this? Then how do you calculate? The calculation is the most important in this video. Mostly the calculation is what you are going to focus on much in this video. So for us to be able to achieve the AC current to DC current, we have some stages. This current has to pass through so that we can get a DC current as the output. So first of all, you have to draw a block diagram. You can see this block here. This is called a block diagram. This block diagram is going to show the stages. We are going to get a DC current from an AC current. We have already known that for us, our power supply is just to get we'll get DC from an AC current, no problem. Now, how do you choose component for power supply? Let's first of all discover the stages of a power supply. Number one is the input. Input. What is the input? The input current, we have said it's alternating current, written as AC, is alternating current as the input. Then we are going to have output. Our output is a DC current. So once you have these two, now let's determine the stages in between. So first of all, this voltage is quite higher. Let's say it's quite higher. Our target is to get 5 voltage DC. Then the input, like for us here in Kenya, is single phase is 240 volt. So from 240 volt to 5 volt, this input is much higher. The first stage this voltage has to pass through is step down stage. Step down stage. So we have to step down this voltage at a manageable voltage, whereby we can be able to manage and avoid the risk of electrocution. So we are going to step down this 240 volt to a manageable level. Then after stepping down to a manageable level, we are going to convert this step down voltage to DC. So after stepping down, it's still AC at this point. So it's still AC here. Then we feed it to the rectification block. Rectification block. So the rectification block, its work is to rectify the main AC into DC. Then we'll get DC here at this point, but this DC will still contain some AC components. Then we'll have to smoothen. We have to remove the AC components from this DC current by filtering. So we'll have filter block. Okay. Then we'll have, after filtering, we'll get as a pure DC, not 100%, but we'll get a clean DC. Then this DC will be fed to another part which will give us the required output voltage, which is called a voltage regulator. Voltage regulator components. This is what is going to determine the output. Now, what are the components we are going to use in step down stage, rectification stage, filter stage, voltage regulator, etc. So number one, for step down, for us to be able to step down this main AC to a manageable voltage, we need a transformer. A transformer is going to perform this task for us. Transformer. This is a transformer, guys. You can see this is a transformer for stepping down the voltage to a manageable voltage. Like, and in this case, you can see to 20 to 12 volts. So will get 12 volt AC from this transformer. Then from there, we feed it to rectification block. The component which will allow us to rectify AC to DC is called as diodes, semiconductor diodes. Now, for us to be able to achieve successfully, we'll use a bridge rectifier. Bridge rectifier. So you can see here, let me show you a bridge. I've built a bridge rectifier here. It's made up of 4 semiconductor diodes. Okay. Then we'll get a DC here at the output. Now this DC, as we have explained, that it still contains some AC components. So we'll have to filter. So in this case, in this video, we're going to use a capacitor filter. So there are so many different types of filter, but in this video, we chose a capacitor filter. Capacitor filter is what we're going to use. This is a capacitor. I'm sure that we have come across this. We have come across these components. This is a capacitor. Okay. Then at the end, we'll have for voltage regulator. Voltage regulator is an integrated circuit known as an IC. So it's already built up and it gives you your required output. So this is just a voltage regulator. As you can see, guys, this is a voltage regulator. Now, guys, let's open these blocks. So if we open these blocks, this is what you are going to get. Now this is the electrical and electronic symbols for this block as we open this block. So we have opened this block. This is the symbol of a transformer. We normally write TX. This is the symbol of a single diode, this one here. Now a bridge rectifier. Now this is a bridge rectifier. You can see it's made up of 4 semiconductor diodes. Then this is the symbol of a capacitor, C. Then this is a voltage regulator. You can write it VR. Then bridge rectifier. Now that we know that, let's see what will happen. We feed in AC current. It steps down this voltage to a manageable voltage. Like the one we have currently, it is 12 volt. We get 12 volt AC at this point. Then this is fed to this bridge rectifier. So the AC alternating current looks like this. Let me just be in details in everything we are doing. So this alternating current is AC, is normally like this. Then what we want to achieve DC is just a straight line. Okay, dotted or it's a straight line. Then meaning that this one changes direction per second and this one does not change direction per second. So this one, obviously, as it changes directions, it has a frequency, a certain frequency variation. So due to variation, it has a frequency, and this one has no frequency. The frequency here is 0, and this one has a certain frequency. Okay, then let's see how this thing is going to work. This diode here is going to rectify this into a DC. So it will get a DC voltage at output here and a DC voltage at this point. Then it will be fed to a capacitor. So a capacitor is connected here. This capacitor is connected in parallel. One side is positive, one side is negative. This is going to short here. It's short and ground, or it blocks all the AC components. It only allows the DC components to pass through, but it blocks all the AC component. Then from here, we still have voltage which is not straight, which is not smooth, which is not constant. Now we want to get a constant output so that we don't damage the equipment we want to use that voltage. So we'll have a voltage regulator now to give us a linear and a straight and constant output voltage. So let's see how it works. So let's say this side is live and neutral. So we have said that it's changing direction, meaning that at a time this one will be positive, at a time this one will be negative, and this one will change positive, and this one will get negative. So this is what will happen. If this side is positive, the current, the transformer, will step down at this point. So this side is positive. The diode only conducts in one direction. So it will the current will pass through its conduct. So it rectifies. You see, it will go, pass through the circuit, and it returns here. Then returning here, here is in forward bias, but the current flow from a high potential to a low potential. It will not flow here, so it will flow here. Then it will return back to the transformer. So then this becomes negative, this becomes positive. The same thing will happen. The current will come here, then it goes positive, then it goes here. So if you see, it's that we maintain one side to be positive and we maintain the other side to be negative, regardless of the changes in the input. We still get positive on one side and negative on the other side. That is the brief I wanted us to have like a discussions on this operation. In the part 2 of the video, whereby we are going to discuss how to choose these components, how to calculate the value of each component in these circuits, as we have discussed here. How do you choose these diodes? How do you choose the transformer? How do you choose the capacitor? How do you choose the voltage regulator? How do you calculate the output voltage from the bridge rectifier? How do you calculate the value of this capacitor? It is very important. How do you choose this? What are the factors to consider of each and choosing each component in this circuit here? So guys, let's meet in part 2, which I'm going to upload next time. Make sure you watch full video so that you don't miss any of the most important part. Thank you. Let's meet next time in a few.